Okay, perfect. Can you guys hear me? Yeah, good. This is a very cozy setup. I like it. So we have a good hour to spare. So I'm Carl. I'm with Avassa. I'm the CTO and one of the co-founders. And well, you've likely read the topic of the day. But what I wanted to say was that I think this will be a way better presentation because a lot of it will be about my experiences and observations. If you ask questions, if you have them. It'll be weird to just tell you what I think and I feel and I experience and not get anything back. So I would love for you to just raise your hand. I've been informed that the best thing is if you ask me and I'll say the question one more time in the mic because he's recording and then I'll answer it. But I'd love to get something like going back and forth here. Okay, cool. So with that, broadly speaking, the agenda, there needs to be some pacing here. I'm going to make an introduction and put some context to it. And one of the things that's always hard, this is my first time at Hannover Messe, definitely the first time with you guys, is that I'm worried about finding the right level. So I'm going to watch your faces as I talk about some of the technical details, and you tell me whether I should go higher or lower, or if you think it's the right level. I have a pretty strong background with containers as a general technology from a couple of actually kind of contexts and products. But the industrial setting is new to me since about 5 years. And you will find that to be true throughout the entire presentation, is that I'm bringing my container experience into the industrial setting, just for you to understand where I'm coming from. So this will have a pretty clear angle about that. And then the company that I work for and the product that I'm going to show you some screenshots from is obviously a solution to manage containers in industrial environments, which means two things. We have actually implemented the thing. It took a couple of years to do. So we have a lot of observations from actually implementing software to do that. And we're also fortunate enough to have customers. So we have worked with customers to introduce this, right? So my angle here is to kind of share the observations of both implementing and introducing a solution stack to this environment, and then of course trying to start to bring it all together and then draw some hopefully interesting and useful and maybe even actionable conclusions to it. All right, and also try to keep on time. Introduction. Okay, so this is my first thing, like, do you guys know what containers are? Application containers, like Docker containers. So, okay, so careful nodding. Okay, good. I'll dive a little deeper, but then I don't have to go so maybe not so high up. The really interesting thing for me on the vendor side is, of course, the fact that it's truly become, without being a formal like standard, it's become welcome. Have a seat. Yeah. Without being a traditional like IEEE or such standard, it's become a very, very strong, solid foundation for, I can't remember a single company that I've talked to over the last 2 years that doesn't say we think containers is the universal packaging format for applications running in Linux and Linux-like environments. So it tells me two things. One, that people don't hate it. They don't think it's bad. And number two, maybe more importantly, there are no real alternatives right now. So in the kind of pace that we have in the industry for the coming foreseeable future, 2 to 3 years, I think containers will maintain that position. And of course, at the heart of it, it's a standard unit of software. So it's a way of packaging your application and packaging the actual required surrounding, usually libraries, so that you can run it across various types of environments. If you talk to people in the development team, it's usually about being able to run your application build both on the laptop, in the testing harness, and in production without worrying about versions of kernels and versions of libraries and version collisions. So of course the container term comes from the whole idea of standardized container sizes. You can put things on boats in an efficient way. And just in terms of terminology, of course, you have some sort of infrastructure server in the bottom. You have a host operating system, predominantly Linux, even though there are container support in others, that is the mainstream. Then you have a container runtime, and normally people associate this with either Docker or Podman from Red Hat. Those are the two dominant ones. There are some niche experimental things, but it's usually Docker or Podman. And then, and here comes a little bit of terminology, you have a container image, which is an archive file. For people with Unix background, it's more or less a tar file that you stuff known things into. So that's your image. And then you give the image to the container runtime. It knows how to unpack the content of that archive and start it. And then it becomes a container. You take a container image and you run it through the container runtime, and then you have running containers. That's basically how that works. The really interesting thing is that that's, of course, at the heart of it and what people intuitively think of. But as a vendor or someone who uses this in a commercial product, what's also very important for us is that there's a lot of surrounding tooling that is used to manage the life cycle of containers, which means for us that since we build something for a container environment, we can assume, welcome, and kind of build on the fact that, for example, there's an industry-wide standardized way of publishing a container image. If you're someone who needs to publish a container image, you can use what's called a registry or a repository of registries. And then clients know how to pull container images from that. So the whole way you publish and fetch applications is also now well known, has multiple implementations. Maybe contrast that with the virtual machine world, or for that matter, the Linux world, where there's a wild mix of HTTP or FTP and files that you have to extract and install and all kinds of things. In the container world, we do Docker or Podman pull and Docker or Podman init and run, and that's it. And it knows how to talk to a wide variety of implementations of registries and repos, which is also a massive improvement over life from what it was before. And there are more things to that, so things like monitoring and observability, standardized logging, for example, which is a little bit of a weird thing. Applications in the container world usually just print to what's called standard out, and the container runtime knows how to read that. The good thing is that you don't have to fix your code. You don't have to align or configure things. Usually the container runtime you run on knows how to pick that data out of the application and to publish it. Updating applications is the same thing. There's kind of well understood patterns how to kill off one container and then have traffic moved over to another instance, maybe of a new version. And all this together, not just the packaging format, of course, has driven a lot of the kind of paradigms around applications adhering to microservices, and you have the whole SRE and platform engineering kind of cultural mindset because of, again, containers as a packaging format, but also the tools and the processes around it, which to me is probably more valuable than the fact that it's a tar file. Very important. And I know this is a little old. Nowadays, people usually don't think of only Docker in the middle. But there is, of course, pretty crazy amounts of support for containers ranging from the repo world, operating systems, big data management, and of course the cloud giants, to the point that when I talk to younger engineers, or let's say in their mid-20s, that's pretty much all they know. They don't have a long background in native Linux applications, or for that matter, virtual machines. It's so pervasive that it's now coming out of the educational system, right? Containers is just more or less a no-brainer at this point, which is pretty fast, even for our kind of nervous industry. It's only maybe 10 years since I'd see Docker for the first time. And of course, if you ask our beloved friends over at the analyst firms, they would tell you that there's a couple of interesting tailwinds. And here I'm doing a little pivot towards talking about containers running at the edge or outside of the cloud, let's say. There are two kind of finer points here. One is that containers are, as I tried to show you on the illustrative picture, it is a part of the whole idea is that you can run several applications on the same host. There's always details about the level of isolation, but the whole idea, of course, is not just to run one application, but to run many, lightweight applications, kind of independent from each other, but with well-known patterns to talk to each other. And that's, of course, really good if you have microservices-like environments, even at the edge. And this one is huge for many of our customers. We usually work with enterprises that, for some reason, needs to run applications at the edge. And of course, the industrial environment then is one of the reasons. They usually always have pretty decent amounts of investments in IT tools already. So for everything that they run in the cloud, because they do run in the cloud, they already have ways of deploying, they have ways of monitoring, they have ways of upgrading and hardening and security testing and all that kinds of things. And those are almost all exclusive to containerized applications. So for them, it's also a great opportunity to kind of get full reuse of what they already know and what they've already invested in, and kind of make the edge or make whatever distributed domain they're in as an extension to what they already know. So there's a lot of value, at least from the C-level, in understanding that one good thing here is that you also don't have to reinvent the wheel and build a whole different IT operation stack just because it's running outside of the cloud. But if you do this carefully, you can get a lot of traction of what you have. Okay, so now I'm going to bring that container knowledge and what I know about this and try to carefully apply it to the last couple of years where we've done it in an industrial setting. This feels weird to show people at Hannover Messe, because you guys probably know this better than I do. What we get back from customers that are looking to introduce containers in kind of an OT or what's traditionally called an OT setting, of course, we always ask them why. What is the change agent here? Why aren't you staying with what you have? And it's usually those three. Monolithic, meaning I have to rely on a single vendor's goodwill, right, to do feature growth for me, and I'm usually not in front of the line because I'm not the biggest customer they have. The second is very common. Like, I want to get to my data close to the source. But if I work with a single vendor monolithic solution, it comes out of a weird dashboard in the middle, and I can't get it to it early enough that I can play around with it and do other things than what that vendor wants me to do. And the third one, I could almost like strike it out and say AI, because every conversation almost that we have here, what they mean by third-party workloads is to try to use inference, some sort of easy statistics or inference close to the data source. And they want to do that with whatever vendor or other types of solutions that they have, but close to the data source. So that's kind of what we hear, is why are they going away towards something that looks a little more like IT and kind of introduces the containers that we're talking about here. Does anyone have anything to add to this list? Otherwise, I'll just move on. And again, with kind of maybe a little simplified, but the way we look at it is, okay, so you're going to have, of course, you're going to have all the physical manifestation of whatever the location is doing, in terms of sensors, actuators, traditional physical PLCs. My experience comes from environments where they then introduce some sort of IPC running Linux. And there are many ways to this. It can be very, very, very simple, like someone has a manufacturing plant and they just want to read out data, so they literally just attach we work with a company called OnLogic. There's an OnLogic PC that has some sort of interface. All the way to working with machine builders that has a new generation of some sort of a machine, and they've introduced an industrial PC at the heart of it and kind of wired it up to certain parts of their machinery. Of course, inside of that application layer, there's usually, broadly speaking, two things. One is data collection. The other one is influencing the physical world outside of you, which usually, for us, comes in the shape of some sort of virtualized PLC or containerized PLC. Might be other things usually related to data, and then comes AI. Some sort of, I want to read the data, learn from it, or take decisions on it and send the results somewhere else. And of course, even in this era, especially around things like both, how do you program the PLCs and where do you send the data, there's always data and cloud integration, right? So they always send off the results somewhere to show, or they have a development environment that tells the PLC what to do with some sort of regularity. And of course, what we hear is good about this is that in this case, you can literally go for, best of breed generally. You can pick the sensors, actuators, PLCs that you like. You can actually see if you can, find a PC that you like better than the other at a price that you like better than the other. There's usually a lot of religious discussions about which Linux. For some reason, that's still very interesting to many people. And then you can actually pick and choose and mix vendors for these things. Depending on your appetite for integration, you can literally go and shop them, and try to make them work together. And of course, the extensibility gets there, and we also know that there's a lot of uncertainty, like I don't know what's coming next, so I would like to save some space here to see if I have other things coming in. Now that I'm learning more about the data that's flowing here and the behavior, I might want to do other things like local displays or other ways of managing or doing interesting and valuable things to the data. So that seems to be kind of the, let's say, the positive driver towards this kind of stack. And then if I try to make kind of the connection between the container technology and the OT environment, right? Portability and consistency seems to be very, very high up. A very common pattern is that I want to run my PLC in a fully digitalized, like digital twin or some virtualized environment, and I want to test things out there before I introduce it to the actual factory floor. So being able to have the same kind of development environment and then some sort of testing environment and then the production environment seems to be a driver. Rapid deployment is really interesting, and scalability kind of comes with that. Being able to quickly, as in faster than months, get things up and running, maybe in a canary fashion, you try it out somewhere, and then because you know that you will fail 9 out of 10 times, have a cheap way of pulling that back, so you don't have to do hardware lift and shift and things like that. Seems to be a very strong offering here. Isolation and fault tolerance. An interesting part of the container ecosystem or the container runtime is that as far as the Linux kernel can muster, it's conducive to allowing things to fail without impacting other things. I mean, the general, I guess, IT way of saying it is that we've tried to move away from monoliths into then modularized or modular microservices. And the whole idea of having a container runtime and a monitor for that is that you can allow, for example, replica failovers, you can allow for rapid traffic shifting. So there's a lot of things you can do around the fault tolerance and the isolation between your code modules. So one failure, if you like, doesn't actually impact the entire setup. Maybe some people are talking about it that you can minimize the blast radius of mistakes, so it doesn't actually impact on a system level. And of course, being able to leverage on that whole ecosystem that I said, and not tied to the particular vendor, but actually be able to reuse, if you like, a whole slew of things that's ranging from full open source to a full IT range of tools, seems to be also something that has a very positive impact on this. This has been a very interesting 2-3 years and many conversations around this, and it's a little dependent on the actual nature of the application, but I felt it's useful to talk about like this. Maybe 2.5-3 years ago, we saw a big swing towards full cloud. So people were maybe over-rotating on putting as much as they possibly could in the cloud. What they found was that it becomes very, very exposed to and sensitive to any type of outage in the infrastructure between wherever things are happening and the nearest cloud data center. So a pretty rapid shift back. But I think the last bullet here really, kind of swung the pendulum a little bit back, while of course everybody understands that some of the really interesting features of full cloud with things like feature growth and the ability to turn on and off things really fast isn't really available in the fully on-prem world. So of course we've seen some decent stabilizing effects around the hybrid cloud model here. You can keep your latency low where it actually matters. You can keep the security tight where it actually matters and where it's actually hard, which is of course in the local environment. The scalability can be very good, usually means that you can scale on the physical layer and have your cloud elasticity meet whatever data increase you have. And the reliability within industrial operations is kind of kept in this kind of hybrid world. So I think from our point of view, first we saw the full cloud swing and then back to maybe a little over-reliant on on-prem, and it seems to be settling on the hybrid cloud kind of model now. And the way we see it is that for every application we see running in the local and the on-prem environment, there's always a corresponding component in the cloud. There's never, one or the other. And there's a couple of really interesting challenges that comes out of that. It means that if you're upgrading or updating your application, you usually have to touch both. Like it's one big release cycle that touches both infrastructures. Right, so let's go to kind of more of the experience and the feedback. 4 things that we've found kind of our users and some of our customers not stuck in between, but having to consider. So this is a little bit of a versus setup here. And I'll see if I can translate that into then tangible suggestions, that ways we've seen people kind of balance their way out of kind of that maybe a little stuck position. Yeah, let's go through them one by one. So of course, this is, for me, that's kind of new. This is the one I get the most as a feedback. There's no way we can use, usually whatever part of the container ecosystem, when you're really close to high-speed arms, or when you're really close to things that need hard real time. And that's pretty obvious, of course. The type of solution stack that I showed you a couple of slides ago doesn't solve everything for everyone at all times. It needs to be carefully applied. And we see this interesting, of course, balancing act between the predictable and at least soft real-time control and the baggage maybe that IT teams bring with them, which is maybe a little too little interest in those kinds of aspects. So it becomes a really strange kind of in the middle situation. And the fact that, of course, and this is kind of goes to the rightmost column, cloud latency is just an absolute deal breaker. And so we've seen a lot of users go to, of course, the hybrid architecture, and then maybe default by thinking that, or trying an idea that we can probably do well with a tuned Linux kernel until we can't, and then apply actual hard real-time only when it's needed. And we've seen not all occasions, but some occasions we've seen surprising results that the environment that actually requires hard real time is smaller than maybe what they planned for or thought from the beginning. And a huge thing here, of course, is that if you try to actually do as much as you can in terms of data processing, and that's the underlying data set for low latency, then you can meet that kind of halfway situation, so you can still do all low latency decisions even though you keep your feature velocity with the cloud. So trying to kind of have a reasonable data-centric architecture locally is really important, because then you can start inserting decision-making software there and kind of keep the latency low. Okay, another big one. I have a long background in networking, but I was still surprised about how specific the networking and the kind of infrastructure security posture and security policies in OT is or was. So of course we see this interesting tension between how OT networks kind of assumed air-gapped security, which kind of flies in the face of that hybrid model, if you actually mean it by air-gapped. And certainly a lot of cyber threats targeting industrial control systems. The whole Cyber Resiliency Act is coming at us with a high speed here. And remote access in some cases can be pretty new as an idea. By remote access, I usually mean like you have some sort of operation center, and then you cover from that operation center several plants. So literally not inside of a plant, but across plants. The good thing, of course, is that the underlying problems here can be solved with known technologies. So things like zero trust security for the OT networks, meaning that you never trust anything. You build a trust-anchored based architecture, and you always whitelist and don't allow anything except what's known. Network segmentation in our product, for example, is very, very important. You want to make sure that you protect traffic between components, but also between hosts carrying components. So there's never any vantage points inside of the system that's not part of the application that can read or understand the data. And of course, that whole secure remote access from the plants or from the premises to some sort of centralized environment. Hopefully something like a VPN or SASE solution or zero-touch networking that kind of hits the industrial DMZ and goes all the way back to maybe not the cloud, but maybe to an on-prem data center that carries the control plane. Seems to meet most of the issues here. Yeah, legacy integration versus future-proofing. So scaling out, of course, the infrastructure, and usually means adding new compute or adding new machines with compute. To do that without downtime, so you don't have to stop what you're doing just because you're adding capacity or adding applications. Things usually actually stretches across the kind of boundaries of the machines and at times also across the boundaries of the sites. So you want to do things that covers more than one location. Can be a tricky thing. And of course, this is a very, again, recurring pattern, maybe to the point that we're a little fed up with it, is that AI and automation adoption really requires some sort of architectural rethink with more open interfaces and more open components. And of course, no surprise, I think that containerization will help quite a bit with the first 2 points here. It becomes really nicely scalable and flexible, depending on the needs. And the balance between cloud and edge gives you that real-time control. And if you have kind of an interoperability first mindset and build heavily on known interfaces, like if you use Linux, if you use containers, if you use networking constructs like VXLAN and WireGuard, you know that there will be broad vendor support for it, and you will be able to scale out also kind of in the vendor space, and you know that at least in the short to mid-term, whatever future applications you're going to rely on will work in that setup. This one is also kind of new to us, interestingly enough, because we have a kind of a solution that spans both, let's call it the traditional wiring and the infrastructure, all the way up to the applications. We get to talk to both OT and IT sides of things. They do have different priorities, tools, and expertise, and over and over again, it's so interesting on this show floor to talk to OT people that have kind of application layer first, and then their interest starts waning down the stack. And whenever it comes to choosing server hardware, for example, they couldn't care less. And I'll tell you from an IT vantage point, it's the opposite. They take extreme interest in hardware, and then as you go up the stack, they start thinking about other things, and surely that's someone else's problem. And that's also a little bit at the heart of this, because if there's not a really, really nice and clear channel here, IT will underwhelm OT, and OT will probably never really be heard or understood and met with the kind of infrastructure that is needed. And of course, with the baggage that exists in some of the parts of the industrial environments, the complexity of actually being allowed to change things in terms of paperwork or in terms of signatures can be significant. And if we don't take our time to actually introduce carefully, but in a structured fashion, the types of technologies that, for example, I'm talking about today, it will not be good. The types of solutions that comes from both camps usually has a hard time talking to each other, and that kind of falls on the vendors a little bit as well. So of course, we spend quite a bit of time here, really trying to listen to people that we don't know from many, many years, like the people in charge of PLCs and maybe OPC UA implementations, for example, to really understand what they need. We've also found, to a surprising extent, that the closer we get to IT, the more they appreciate actually our web UI. And that's not even a joke. If you talk to IT people these days, they're usually deep in YAML and JSON and VS Code and all those things. While the closer we get to people with an OT background, they appreciate kind of low-code, ClickOps environments. And we're happy to serve both, but it was a surprising kind of mix between the two teams. And if at all possible, see if they can make it a process collaboration so they can align the goals and the workflows to get out of things like stuck with different types of trainings and worldviews. All right, so where are we? That's good, perfect. Now I've been talking for a long while. Any questions or any comments this far, you guys? Yeah. So I'm gonna summarize the question. What are some of the legal maybe challenges with introducing these kinds of technologies in existing environments? So I spoke to a very interesting vendor on the show floor today. What they do is that they host PLC environments in the cloud. So they can take, PLC IDEs from several vendors, and they tell the customer that you can install your IDE in our cloud environment using your key, your license key, right? And so I asked him, how is that going? How does those vendors actually react to that? And he said, and I think this reflects our experience too, it is the entire spectrum of people going, that's amazing, you should do that, we're going in the same direction, eventually we will offer the same, it's good that our customers get to know that too. People that are very, very, very upset. So, I mean, maybe not naming names, but depending on the existing position in the market, we've seen very, very different reactions to it. The good thing for us as a vendor is that we can just point to the customer and say, look, it's not with me you have that conversation, it is with the customer. And at some, I can also have full empathy for companies delivering full stack solutions, and someone suddenly goes like, I'm just going to put a spanner in here, but I'm still going to hold you fully accountable for it. And of course, there needs to be a balance. But generally speaking, it's if the customer has a firm idea and firm direction, of course, they have the last say. And we have never had a legal thing being pulled on us this far. But it's such an interesting time because it's so dynamic. And there are so many big companies that have so much to lose. And there are so many smaller companies that really want to do well here. And there are then, of course, a customer base that is ranging from let's burn everything down and start from the ground zero, and to let's do this carefully. So it's a very interesting time right now. Yeah. Any other questions? Cool. All right. Okay, now I'm going to slowly move towards more of a solution-oriented mindset, and I will flash eventually some screenshots from our product to make it come alive. I will say there are other products, but I think that, it's a good way of illustrating, I guess, what I've been talking about here. Okay, so just to tell you about the scope of the solution that I'm representing, and therefore kind of frame, how I'm going to answer it. So we are a software company, so you can think of us as a layer between Linux and the data and cloud integration. So we don't sell any hardware at all. We don't sell any industrial PCs. We partner with, and I've spent a lot of time with vendors of various makes here just to make sure that I understand how they work. Our customers have some sort of industrial PC that they like. They install whatever Linux they like. We have partners in that sense as well. Of course, they already have this infrastructure. Then they use our platform to manage the containerized workloads. So we don't have a PLC or an MQTT broker or any data ingestion or anything like that. But we think we are pretty good at managing the containers that carries those applications, including a lot of MLOps and AI companies. So we are for organizations that have, I guess, enough number of hosts and enough high change rate that they need to automate, and that they want to use a little bit of an IT approach to monitoring and observability. So it's not a full stack by any means. It's one piece of the stack. It's just, to me, a super interesting vantage point because we get to see what's going on down here. We get to talk to all the software vendors in here, and we get to work with them to make sure that whatever they're doing is also easy to integrate with the cloud. And generally speaking, as I said, it's usually some sort of data, some sort of PLC, and then some sort of AI. And usually, again, we run on, let's call it, industrial PCs, so x86 or ARM, with the Linux on it. Okay, so first thing, again, that people spend a lot of time on is picking a Linux. Linux is born and bred in the data center or on your desktop. It has some ways to go before it's perfect, let's say, for a distributed remote environment. we always suggest people don't look at them as separate, servers. Try to look at it as a fleet of something. Try to look at it as a, some people call it a herd of cattle, not as singular animals. It's a herd. Number two is something that comes way too late in the conversation with many of our customers. There's a way for the IT industries to publish vulnerabilities of various criticality called CVEs. There are public ways to figure out who they are. You definitely are going to eventually need a system that says, I know which Linux version I'm running here. There are now 2 critical CVEs because eventually the Cyber Resiliency Act will force you, or force all of us, to do something about that inside of about 48 hours. A structured, automated way of tracking vulnerabilities and do something about them. And you have to think about the fact that Linux is both a kernel, like the heart of the operating system, but also user-land applications, supporting applications. They both need management. CVEs and activities happen in both layers. They are somewhat different in how you manage them, but you absolutely need to take care of both. Surprising amount on this show floor says we don't care about this, we only track the user land. So when a critical CVE hits the kernel, they are in deep problems, because that can be a little more upsetting to change or to update. So think about it as a fleet and make sure you have tooling for tracking security vulnerabilities. Yeah. Onboarding, meaning the way you bring up a new host or you bring up new infrastructure, is another thing that is very well understood and very well done in a data center. It has a slew of interesting challenges when you do it in a distributed fashion. One thing that is a very, very important thing for any company trying to build something like what we have here is that we have no customer that would ever allow networking sessions from a centralized, much less the internet, into the plant or on site. Everything must always start from the edge. So whatever process you have for bringing up a node can't expect the outside to connect into the site, but must always have something that connects out from it, and then you go from there. The interesting thing with that is that, of course, somewhere in the upper layers, maybe there's always some sort of commercial firewall or load balancer. They don't like proprietary protocols. Actually, a proprietary protocol could be a knockout no from some types of environments. So build it on whatever these commercially available firewalls and load balancers know. In our case, it's a combination of what's called MTLS or TLS and QUIC, which is 2 pretty basic protocols. They serve a good purpose, and the best thing is that every firewall manager in the world knows what they are. And that's not enough, because then when you are called home, you need to have the ability to talk in both directions. So you have to have some sort of transport session built on via onboarding that will allow you to both write things and push things to the edge, but also read things. So take that into account and make sure to align with whatever. I've heard conflicting things about ISA 95. Some of our customers use that as a network architecture thing, and some people use it more as a policy or role or even process and organization. But aligning with ISA 95 and making sure that you have the components or pick the components that can support that is probably good. Packaging applications, of course, nothing that will surprise you based on what I've said before. You need an efficient and open way of packaging the applications that your vendor support and that your internal teams know and love. Of course, cloud-based tools like Docker and Kubernetes is already around. People are usually running that already. So pick something that can work with those. We also find that, to a larger extent than we thought, our customers don't take pre-packaged applications from a vendor and simply just install it. They take it and then they calibrate it. They configure a little bit, they add some components, they may actually change some configuration parameters, which means that there's always someone in some sort of application team that's in charge of the final packaging. They don't rely fully on the vendor for that. So we need some sort of support for that as well. And of course, it gets a little detailed, but we need to both support applications intended state, meaning that this is how this should behave, and then also the configuration that leads to that. So in our world, we usually see that you should think about applications and their configuration as 2 separate entities. You should probably lifecycle manage the configuration in one way because you want to tune things over time, and the application version as a separate thing, usually with a lower cadence. So this is then the first screenshot that I'm going to show you. Let's see if I have a pointer. Okay, so just to give you a brief overview, this is actually how our application is being used to package an application. So on the left, if this is a web UI, of course, there's the things you can do. And we find that as an application team or as an OT person, what you're usually mostly or sometimes mostly interested in is what are my applications? And the secondary interest is where are they running? So in this case, you can see that we have a set of things that usually our customers or people that are interested in talking to us wants to see. We have a Mosquito packaging, we have some Node-RED, we have ROS2 for the robot people, we have WASM for people that are kind of forward-looking and wants to look at WebAssembly, and then we have 2 types of AI applications. And the really cool thing, again, for us, but coming back to the initial phase of the presentation, was that application packaging is more or less a solved problem. So we didn't have to invent much. We didn't have to do research and development. Tools like Docker Compose and Kubernetes already provides a well-known structure for telling a system like this, what is this application? And it usually comes down to the fact that applications have names, they have versions, and they then have a set of container images, which is usually expressed as pointers. So in this case, a pointer to a registry. So this system, as a preparatory step, when someone inputs this application configuration, can proactively fetch the container images and get ready for the deployment. And we literally have, it looks like this because we have 2 types of users. As I said, some people may be, statistically more OT people, they like the ClickOps, they like to be in the web UI, while a lot of people in the IT industry would never be caught dead with a web UI. They like their YAML files and JSON files. So we try to cater to both. And also provide REST APIs for people that don't want to click around in a web UI. But this is kind of what it looks like, and really advanced customers put this in Git repos. So they manage this along with the source code and the packages, and they hand over the responsibility of this to the application teams. All right. Yeah. So we need to deploy and update applications. So that's another thing. We usually, when we demo, we make sure to always demo not just putting an application into production, because that can, at times, just be done with scripts. The really interesting part comes down the line when you need to update the versions that are running. You may want to expand the scope. It's the full kind of day 2 life cycle in terms of deploying and updating the applications. And what we found to be critical here, one is, this one actually came a little late for us. It's really important to allow the applications to formally say, these are the resources that I need to run well. It can range from really simple things like, this is the minimum amount of RAM that I need. Or in a more advanced case, which again is pretty common, I am an inference application. I can't do anything reasonably useful unless there's a GPU that I get access to, because then I will be too slow and no value. And the only people that know what this application actually requires, or if I'm a OPC UA or MQTT, I need sensors to read data from. The people that know this are the people that are packaging the application. So we should give them a way of saying, this is what I require from the infrastructure, and if it's not around, that's actually an error. Don't try to install me where this makes no sense. I mentioned separating out configuration and sensitive data. So typically, some configuration is just about, what IP address do I listen to, what port do I listen to. Other types of data can be things like certificates, or it can be things like product keys, things that you don't want leaking, and things that may need, at times, like time-sensitive operations. You may need to rotate your certificates, you may need to update your credentials. So keep them in a separate life cycle. And as much as we would love the industry to come together to agree on a way to update applications without impacting the way they behave, it's still kind of a mess. So you have to have some sort of flexible approach. Some applications need traffic to be redirected. Other, prefer to, completely remove the traffic from the site. There's a couple of ways you need to do that. That's kind of application specific. And what that looks like in our system, in this case, we have an instance of Mosquito running. So when our application person clicks Mosquito, they get to see where is that running. And is the site available, meaning is it connected? And is the application alive? Is it running? Which is really important, right? And then the ability to go deeper into the operational state, because this is, again, a single container Mosquito application. You look at the service level, that we have a nice IP address. And then on the container level, when did this start? Are there any restarts? Did this application actually crash and restart, which is not uncommon when applications misbehave or fail in container environments? Usually the container runtime is pretty aggressive in trying to restart things with a back-off timer. So that's usually an important signal. And there's something called probes, which is a whole topic on its own. So usually a trio, a startup probe, meaning could the container runtime successfully start and initialize the container? Liveness probe, meaning is it alive? Is the process running, right? And then readiness probe, which is usually application specific, to say is the application settled in and now doing what it's expected to do. It's out of the initial phase and now performing. So this is usually the view that the application teams take for things that are running in actual production. There's a massive amount of other things here. Of course, you want to look at specific containers, maybe open a terminal to them. You want to look at distributed logs and log replays. But this kind of view of having the applications you're in charge of, you click through, you see where they're running, and you're able to inspect their health is kind of table stakes for this. Yeah. Yeah, yeah. So how does a new device connect to the platform, was the question. So I'll make it complex first and then easy. Usually we have two types of customers. We have one that prefers pre-imaged boxes. So they send it off somewhere, and that somewhere installs the Linux operating system, the application. So when you power on, it literally goes all the way up to productive. And the other extreme is that they have IT. In location, they have one USB stick with the Linux and one USB stick with other stuff, right? But what actually happens then is that our agent, based on configuration, will open a TCP or UDP connection to a well-known URL. And that's where the firewall people need a heads up to do that. And for people that are very security forward, they actually manage that connection with client certificates. So they have a certificate on the box, hopefully tied all the way to the TPM. When that session is up, and there's a lot of things that happen, then we can use that long-lived session to go in both directions. Right. Yes. Any other questions? All right. Yeah, we're touching on it. In our world, of course, both the configuration, I mentioned that, and the data are sensitive because of different reasons. This one is pretty recent. We have some companies that are very worried that their model files, their inference model files, their trained models, could be stolen because that's their entire IPR. And so if someone gets to that, that's a pretty severe breach. And of course, in some of these environments, as you guys very well know, there is no perimeter security. People have somewhat unlimited access to the physical compute, which is wildly different than in most cloud environments. So of course, what we think is important here, you need to be able to work with both containers and VMs, and you have to be able to inject this kind of data from your vault or whatever type of way you have of managing your sensitive data into the runtime environment, so you don't leave it as files on the host or any way expose it. You need to be able to tell your VM and container doing this, commonly using environment variables or mounted files, in some cases, authenticated APIs. Crypto is, of course, something you need all over. Interesting thing for us is that if we apply it the way we do, and we do, then we actually get export classified, because this is a general communication system. You can talk to boxes over it. Boxes can talk to each other. So now that we have a more than reasonable key size, we're actually export classified. And so because we understand that the crypto is needed both to protect the infrastructure, but also the tenancy model and also the data and all the applications. And of course, at the heart of many of these things is trust. And this is also a very interesting, huge topic. Most of our customers don't allow the administrators unfettered access to the entire system. There's usually a whole process around how do we constrain roles to very specific things. And specific things can be either, plant level or site level, but can also be action level, who actually gets to deploy, but also data stream or data level, like who gets to listen to telemetry data. So think through the distribution policies and the role-based access to the system. We find is key as well in the rollout. And the way this looks for us, in this case, there's two things that is important to a Mosquito. It's a certificate and then a little bit of credentials to allow it to talk to other instances. In this case, we can look at the vault, what's called the vault content for the Mosquito application. And this is another nice little thing. And what this says is that only distribute these sensitive pieces of data to sites and actually hosts that actually run this application. So we don't spread this out everywhere because that application may turn up on that box, but only follow where this is going. And in this case, it's a subset of the sites. And of course, then this certificate here, of course, is part of the configuration like this. So when you upgrade or update the cert, we need to be able to tell the application that your cert is now fixed. And that's also, there's not fixed, but changed. That's also an interesting topic because there are a variety of ways of doing that. But making that part of the life cycle, we believe are really key to being able to both proactively protect data, but also react to potential problems. Okay. Inter and intra-application network security, because if you build according to, I guess, a container mindset, it's usually 2 or 3 containers talk to each other. If you run on clusters, they may be on different boxes, and that data may be super sensitive. And of course, applications talk to other applications, or they talk to the cloud or other components. And we need to protect both of those traffic paths because they can be sensitive. And it is application-driven traffic, right? So it's not general VPNs from point A to point B. It's usually inter and intra applications, right? So one application shouldn't be able to see the other application's traffic just because they happen to be on the same host and use the same VPN. So that needs to be taken into account for sure, and made part, we believe, an integrated part in how you design the actual application itself and the traffic patterns between the components. And then traffic both, again, inside of the cluster, inside of the host, but also from the on-prem, from the cluster to the cloud needs to be protected. And underlying to this is, of course, you also need a way of managing the crypto material itself. So if you get a problem or if you have that type of policy, you need to be able to, in an automated fashion, roll the keys, for example, or destroy the keys if one application goes away so you don't get key reuse and things like that. And the way that works for us is that as you define an application like this, you actually have a set of configurations. Most of these, which is good for us, is actually related to just common container, container infrastructure and container networking. Some of these things are specific to the edge, but they are pretty few and far between and can be expressly exposed, if you like, as configuration. Is it a metal band, do you think? Or unclear. Very, very enthusiastic drummer. Okay, future-proofing and interoperability. So we have a whole range of applications running now on our infrastructure with our customers, ranging from virtual machines, old-school Windows machines, actually packaged as containers. Would you believe it? You can package VMs in containers and run them on KVM. All the way to more forward-looking binary environments like WebAssembly, which seems to be picking up speed. It's just another way. It's a new bytecode, basically, but it seems to be very, very popular with certain parts of the development kind of community. And we find that as long as we build on open, well-known, and in the container world, OCI-compliant tools, we've been able to manage, again, both VMs, bare metal containers, AI applications with model files packaged as layers, and nowadays also WASM applications. So it seems to hold as the kind of industrial basis for at least the range, the gamut of applications we see this far. And of course, we think that in order to be future-proof, and what I mean by this, for example, is that we now have customers that have maybe 2 applications running on top of our infrastructure. One of the application teams, they prefer ClickOps. The other has a fully automated Git-based pipeline, and maybe they're now thinking about an MLOps pipeline to separately manage the model files. So as long as we stay open and kind of build interfaces for this, they can mix and match as much as they want to and get that nice leverage off of what they already have. And this is what it looks like. Interesting thing for me, this was an experiment maybe a couple of weeks ago when we had a customer interested in running WebAssembly. And we literally built a WebAssembly container, which has no libraries or nothing, it's just the WebAssembly. And the only thing we had to do in one of these packaging formats was to tell the container runtime that there's no what's called an init process. In Linux, you assume that there's an init process, but in the WASM world, you don't need that. So the only thing we actually had to configure above and beyond any other container application was to remind the container runtime to not expect an init. And it just worked well. You see what I mean by that. Technically, it just worked, which to me was a nice kind of a proof point for how pervasive containerizations have become in terms of the whole life cycle. Clustering and failover, yep. In some environments, and this is maybe more specific to certain types of applications, a lot of the MQTT vendors that we talk to feel this is very important, for example. Of course, continuous operations is a priority. You don't want to lose data. PLCs and actually actuators is a different ballgame. The clustering in that part is a little more exotic, but let's stick to the easy to understand. Of course, we want to be able to support building resilient infrastructure. So both planned interruptions, like an OS upgrade, which is actually usually an interruption that you have to take into account for, and unplanned things go south now and then. Make sure that you plan for this. Again, clustering is a cheap way of doing that, and make sure that things happen in the order you think. And this one is huge for many of our users as well. You want to be able to make sure that all your critical servers are local, and you make sure that you understand that there might be hours of upstream outages, maybe even practice that. And of course, if it's actually operations critical, run it on a cluster. Don't assume the mean time between failure of your IPC is good enough for you. And this is what it looks like in our web UI. So this is a site with 3 hosts that have formed a cluster. And we can see that actually the only application running, which was the Mosquito, is running on one of these hosts. So we know that if we inadvertently or if we plan on taking out Stockholm 2, the scheduler will move the application to one of the others. So if you do that for kernel upgrades, then you should be fine. If it dies, you should be fine. Okay, I'm going to speed up a little bit. Yeah, another big topic is when you get things into production, you need to monitor the health. So think about where your probes are, and what kind of telemetry you need from which layers. And you need to always collect and store the logs locally, because if you lose connectivity, you absolutely do not want to lose the logs. So whenever it comes back up, you want to be able to replay the logs, which is a hugely important. You will need interactive tools, like a terminal to the local box, or even a desktop if you're running a Windows VM. Make sure to take that into account, and you will never be able to get through the firewalls, and make sure you run that over some sort of session that you have. So just a brief look at, this is us listening for logs from Mosquito for a particular layer from a particular location. And of course, this is also based on a replay functionality and follow functionality, and you can filter. And this is usually highly appreciated by the application teams. I'm going to skip here. I mentioned most of this. Of course, please make sure to figure out what kind of existing operations are there, and if at all possible, align with that, because that kind of leverage you can get by reusing what's already there can be pretty massive, and also make sure that that is done in collaboration with the teams that own those kinds of infrastructures. And you will find that the amount of reuse can be pretty interesting. All right, really trying to take it home. Containers are flexible, can be secure and scalable, even in industrial environments. We think hybrid architectures are here to stay. Maybe that's an obvious thing to say in this room. Security is crucial and should be at the front and not at the back. Most of the things that are hard have been solved, so apply them correctly. And of course, automation and orchestration should simplify your life, and standing things up for the first time is easy. Day 2, 3, 4, 5, when all the cool kids are gone and you have to keep this running in a way that takes into account that things fail is way harder and a more interesting problem field. And we really think that, I would say, that a large part of the industrial operations will eventually run on containers. If we talk to certain of our partners like Codesys, the PLC vendor, they say that in North America, instead of five years, all their major customers will run their PLCs in containers. Now, they're a vendor, so who knows? But clear signals, very strong signals around the deep containerization of some of these SCADA components faster than, I guess, what we're used to in the industrial domain. We're here. Come see us and get a demo. The screenshots that I showed you will come alive. We're in Hall 2, stand C32 in the startup sector. Love to have you and love to show you this in a more kind of living environment. We also have on our website, avasa.io, a free trial button. So if you actually want to get your hands on this and kind of, I don't want to say play around with it, teach yourself something with it, feel free to click that. I usually see it really, really quick, and I create an environment for you so that you can get it up and running. It comes up with a couple of edge hosts and some applications that you can deploy. I find it to be very meaningful in the sense that you see it actually happening through your own exercise. Any final questions? 2 minutes over time. Well then, thank you. Really appreciate the time. All right.